Hello. In this video, we want to find the angular velocity in radians per second for a particle that is moving in a circular path at 5 revolutions per second on a circle of radius 10 feet. Okay, so looking at this, we want the angular velocity. It's always important to keep in mind what the question is asking us for. Now, it's wanting it not only in, it wants not only the angular velocity, but specifically says radians per second. Now, let's look at what's happening here. We have a particle moving in a circular path at 5 revolutions per second. So, this is a question that's basically asking us, take this 5 revolutions per second and convert it into some number of radians per second. It's a unit conversion question. Notice that the circle of radius 10 feet means nothing to us because we're looking at angular velocity. Now, if we were looking at linear velocity, yes, that would matter. But because we have angular velocity, we don't care. So the angular velocity, we actually know already is 5 revolutions per second, RPS if you will. So 5 revolutions for every 1 second. Now, notice that the seconds can stay seconds, but the revolutions need to become radians. So to do that, let's convert. For every 1 revolution, there are 2 pi radians. So the revolutions cancel each other, and notice that our units are now radians per second. Now just multiply everything straight across and simplify. So we have omega. By the way, omega just kind of looks like a W. It's not really a W, but it looks that way. Especially if you do it poorly like I did here. Omega's kind of rounded. It's a lowercase omega, by the way. Capital omega looks like this. Anyway, multiply straight across. 5 times 2 pi is 10 pi. And if you notice in the denominator, we just have 1 times 1, so I don't need a denominator here. So it's just 10 pi. And for the units, of course, they are radians per second. And there you go. 10 pi radians per second. Awesome. Well, I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.